Hi everyone, my name is Zhamak. I head the emerging technologies at ThoughtWorks in North America. About 3 years ago, my colleagues and I came up with a new approach in managing analytical data. It's called Data Mesh. And Data Mesh was born out of sheer frustration for not getting results from building yet another data platform, yet another data lake, yet another data warehouse. So it's been 3 years since then. We have learned quite a bit. And what I want to share with you is a deep dive into an architectural aspects of data mesh. If you're getting started, hopefully you take some lessons away, how to think about architecture, how to break up that architecture, and where to get started in terms of the technology that you need to deploy. So with that, let me share my screen and we jump right into it. Okay, an architectural deep dive. A quick refresher, I promise to be really quick. Data mesh is a paradigm shift in managing and accessing analytical data at scale. Some of the words I highlighted here are really important. First of all, it's a shift, and I will justify why that's the case. Second, it's an analytical data solution, and the word scale really matters here. So what do we mean by analytical data? Well, analytical data is an aggregation of the data that gets generated running the business, right? It's the data that fuels our machine learning models. It's the data that fuels our reports. And the data that gives us a historical perspective so we can look backward and see how our business or services or products have been performing, and then be able to look forward and be able to predict what is the next thing that a customer wants, make recommendations, personalizations. All of those machine learning models can be fueled by analytical data. What does it look like? Well, today we are in this world of with a great divide of data. The operational data is the data that sits in the databases of your applications, your legacy systems, microservices, and they keep the current states, right? They keep the current state of your stateful workloads. And analytical data sits in your data plane. It sits in your data warehouse, data lake. It gives you a historical perspective. It gives you an aggregated perspective. You can correlate all sorts of data from across your business and getting a historical perspective and be able to train your machine learning. So that's just the definition and the current state of the universe. What do we mean by scale? I think this really matters because this is where we're really challenged. If you deal with an organization that's constantly changing, and I argue that any organization today is constantly changing, right? And your data landscape is constantly changing. The number of data sources that are pouring data into this analytical view of the world constantly increasing. The diversity of those changes. Every new touch point with your customer is generating data. Every new touch point with your partners are generating data. And you have these ambitious plans and proliferation of use cases to use that data. Then you have a scale at the consumer side as well. There's a diversity of transformation. There's not just one or two or three pipelines, right? There are a ton of the transformations that need to happen to satisfy very different diverse use cases. And the speed to that change needs to increase. So if you're living in this world, hang on here and come along because Data Mesh tries to address these concerns. If you don't have these problems, perhaps you can kind of log off and go to a different call. Why is this a paradigm shift? Because it challenges assumptions that we have made for over half a century. It challenges the assumption that the architecture of analytical data, like the ones that you saw with a lake and a warehouse or lake house or any form of those, kind of existing architectures, it has to be monolithic. It challenges the fact that data has to be centralized under the control of a centralized team so that we can get meaning or use out of it. It challenges the fact that if you're struggling with scale, the only way forward is dividing your architecture based on this technical partitioning, dealing with pipelines by one team, dealing with ingestion in another team, dealing with technologies that help you with serving the APIs and data services on the other end. These are all technical decompositions. And it challenges the fact that we have designed our organizations around these technical tasks. Separated data platform team or separated data lake team or data warehouse team from the business domains where the data gets used or consumed. The The reason for that is the problem of scale will not be addressed when the number of sources it grows and the number of use cases grows with this centralized solution. So as the man himself, Thomas Kuhn, who coined the term paradigm shift, says, we can't just reject one paradigm without coming with another one. So here's the solution around data mesh. At a 50,000-foot view, this is a new way of thinking about how to decouple your architecture, how you decouple your data, how you decouple your data ownership around domains. Folks who are familiar with domain-driven design, this should be fairly natural and organic to you, because you probably have already broken down your microservices around domains, your ownership of those services, your ownership of the technology, mapping your current business around the domain of your business. Why can't we just do that for analytical data? Why can't we just say, let's actually break down the boundaries of that monolithic kind of lake based on the domains? But the moment you do that, you find yourself in a lot of trouble. And the very first thing is the silos of data. Now that we have like 50 different lakes instead of one, right? And they're all siloed from each other and don't talk to each other. So one of the architectural and principles of data mesh is that the data is, now we're looking at data from a very different lens. We call it data products. Data shall be served as a product, which means it has some form of a baseline usability built into it, the behavior that makes the data usable and interoperable with the rest of the data products and domains, make it natively accessible to the user. So if a user comes and finds your domain, whether that user is an analyst or a data scientist, they have very different access mode. Their access mode will be satisfied right then and there, accessing the data and the domain. The other problem you find yourself with is the cost of infrastructure suddenly grows. Now every team needs to maintain its own very complex infrastructure to run those data pipelines, to serve those data products. So we need to think about our infrastructure, the data infrastructure, in a self-serve way, a bit differently. We need to create a new logical layers of infrastructure that really makes it easy to build and serve and discover these data products. And finally, in a distributed fashion, in a distributed architecture, we need to think about how we are pragmatically going to make these data products interoperable, making them secure, not compromising privacy. How can we do all of those things when now we've decoupled these data products across the enterprise and smeared them kind of all over the place, right? So this computational federated governance is a 4-pillar, but in each of these pillars have an architectural implication, and that's what I want to walk you through. So again, at a very high level, the way you can imagine this architecture at an enterprise landscape is through this lens, that while you still have this operational data plane, analytical data plane, which storing and providing access for a very different kind of data. One, the data on the inside, right? The data that is stored in the microservices databases, and one, the other is the data on the outside. Data products that gives you data, expose your data and your historical data over time, an infinite log of your data, an infinite, kind of temporal of your snapshots, however you want to expose them, is now both kind of combined together across your domains. So one domain team, and I'm going to use the example of the digital media streaming, your podcast release team, or your artist payment team, or artist management team. These teams will not only take care of the applications, but also the analytical data. To do that, we have this multi-plane analytical data platform. So I'll go through the capabilities, some of the capabilities, to get a feel like what are these new platforms that we have to build to self-serve these domains, to build those data products. And we will have a set of kind of global governance and policies in terms of how we're going to control access to each individual data product at every domain. How are we going to make the schema language consistent across this domain? How are we going to make the IDs of their policies, the data that goes across these domains, consistent so we can join them? So there's a bunch of global policies that we're going to automate and embed into each of these data products so that practically we can still have an ecosystem that nicely plays with each other. So data mesh at a very high level, and people I know have a hard time getting their heads around this. It's both an organizational and architectural and really a technical technology shift. But today, let's focus on the architecture. So the moment we distribute our data across the boundaries of domains and apply the strategic design patterns that was introduced with Eric Evans right at the end of his seminal book on this, we find ourselves with a very different kind of view of the world, right? We start kind of pulling that big monolithic data apart around the functions of our business, not the technical functions of our monolithic data warehouse or data lake, right? So then every domain, every bounded context with its team, with its systems, has two lollipops. These lollipops, I use them as an indication for interfaces to that domain, capabilities and APIs or whatever interface mode of interface you want to provide to the rest of the organization. And now we have two interfaces, right? Two set of capabilities. One is, I use a notation O, lollipop with an O in it, your operational capabilities, your APIs, release a podcast. And then you have now this D lollipop, which gives an interface into your domain, an access point, an endpoint in your domain for sharing the analytical data from that domain. So let's give an example. Look at an example. You have various domains here. You have your user management domain that, the people who build the microservices or services applications that are registering our users, right? The subscribers to our podcasts and media streaming kind of playlist. That domain will have an API or a system that registers users. And now we'll have something else. We'll have a log of user updates forever and ever. Maybe we want to publish these user updates on a daily batch basis or event basis. Those are all your choices that make sense for your organization for that domain. Let's look at a podcast, right? So we have a podcast domain, probably has a podcast player in it, right? The applications that actually people run, podcast microservice, whatever application you have, and you have the operation of create podcasts and release podcast episodes. But in addition to that, having an access to podcast listens demographic is a pretty good analytical data, right? So to get that demographic, then you will have to probably use data from your users. So there's a flow of the data still within the domain consumption serving data and consuming data between the domains. Or top podcast daily. What are my top 10 or top whatever daily podcasts? So these are some of the analytical data that now the domain provides. If you think about data as a product, now we have this kind of hexagon that I casually drop all over my diagrams. And nobody really understands, but hopefully by the end of this, you will understand what it is. We have this data product as a new architectural quantum, as a new unit of architecture. Architecture of quantum is a phrase that evolution architecture introduces. Essentially, it's the smallest unit of your architecture that has all of the structural components to do its job. So in this case, I need all of the structural components, the code, the storage, the services, the transformation logic, everything, so that I can provide that top daily podcast to the rest of the organization. So it's the smallest unit of your architecture. So what does it look like? If you zoom into that domain, now you've got your microservices, legacy application, that box that implements your lollipop, your operational APIs. And right adjacent to it, you have one or many data products within that domain that they have two very key interfaces. One interface is input data ports, the set of APIs, the set of mechanisms by which you will be receiving and pulling data or receiving data, however that you have implemented that API to get data into that data product. And then the operation data product operates on that data and then provide it as an analytical data on its one or many output data ports. That essentially becomes the interface for serving that data and its metadata. We get to that in a minute. So let's zoom into that previous example. That user domain has user registration service. Right next to it, it has perhaps a user profile data product. I've made these things up. Yeah, it might look very different, but just to get a feel for it. And this user profile data product is just receiving data from user registration service, but it serves two different data product output ports. It gives you your near real time, let's say user profile updates and user registration updates, let's say as events. But it also thinks that if it provides, because of the consumer and because of, let's say, the needs that the organization had, it also provides monthly dumps of the user profiles that it has. What are the user profiles, users that we have this month versus last month versus the month before? And in that podcast service, we have now, let's zoom into that podcast listeners demographic data product, right? It has two input data ports. It gets the podcast player information to say who's listening to the podcast. And it gets the demographic information, the age, the location, the geographical location, all that sort of kind of demographic information from the user profiles, and just transform them and provides them as podcast listeners demographic. And you can imagine marketing would love this data, right? They can do so many things knowing the demographic of people listening to different podcasts. So what is this hexagon? What is this data product? Well, again, if you look outside in, before jumping into the mechanical bits in it, it's a thing that needs to have these characteristics to be a product. It has to be easily discoverable independently, easily understandable, have good documentation, has to be addressable, right? Independently, interoperable with the other ones, trustworthy, has to have SLOs, so it can tell us in what intervals and intervals the data gets produced. What's the difference between the variance between when the data was captured versus the data was processed? What's the statistical shape of it? Like all of those SLOs that it needs to guarantee for somebody to actually trust this data. It has to have this polyglot form of providing the data, because it has to be natively delighting or providing access for a very large spectrum of mode of access, right? Data analysts use spreadsheets, so they want to hook their spreadsheets or data warehouse or reporting system into a SQL engine or some port that can run SQL queries locally within this data product. Data analysts, maybe data scientists, on the other hand, they're totally happy with semi-structured JSON files or Parquet files dumped on some blob storage, as long as they can traverse that storage across time. So they have a very different mode of access. So it's very important the same data is presented and accessed in a kind of a polyglot format. So then this data product, what are those quantum, the structural elements? Definitely needs code in it, right? It needs code in it for the transformation. It needs code in it for serving the data. It needs code in it for embedding the policies, right? Who can access this data product? What sort of anonymization we need? What sort of encryption we need? And a ton of other kind of transformations that make sense to analytical use cases and not so much make sense to, let's say, microservices APIs. Do we need to apply some sort of a confidential kind of privacy and differential privacy? Do we need to give some form of a synthetic data that represent the statistical nature of this data, but not the data itself? Can I see the forest, but not the trees, right? So these are kind of policies that can be embedded and executed by the data product here locally. Of course, we need the data itself. So what's in that data? We have the polyglot data access, but we have a bunch of metadata. We have the SLOs, we have the schema, we have this syntax and semantics, we have the documentation. Hopefully you have computational documentation. We have the policy configurations, and we need to depend on an independent segmentation of our infrastructure, right? If each of these data products are autonomously can be deployed and serve their data, then the physical infrastructure needs to give a way of providing a logical decomposition of infrastructure. They don't own the infrastructure necessarily, but they are able to utilize a sharded, kind of separated infrastructure for just that data product without impacting others. So then if you think about now all of the infrastructure and the platform that needs to fuel building these hexagons and serving them and discover them, what does that look like? So our thinking so far is that we need 3 different categories, I'll call them planes, different classes of a programmatically served capabilities at the infrastructure level. Down at the bottom of the infrastructure, you have this already. You've got the utility, what I call a utility plane. You have a way of orchestrating and provisioning your Spark job. If you're using Spark for transformation, you have a way of getting a Kafka topic. You have a way of provisioning, service accounts and storage accounts. So these utility layer kind of capabilities already exist, and there are APIs, and hopefully you have written, your infrastructure as code to be able to, for someone to call an API or command, or, send down a spec to an API to provision them. But that's not enough. If you think about the journey of the product developer, from the moment that they say, oh, I think I need an emerging artist data product because I want to know what the emerging artists are. I want to run a machine learning model across a bunch of data from different sources, from the social platforms, from our playlist to see who are the emerging artists. They go through this kind of value stream, right? They go from mocking a data product, maybe work with synthetic data first, try to source and connect to upstream data products or microservices or whatever they need to get their data in. They need to explore that. And once they think they have a case, then they've got to kind of the bootstrap building this data production ready and deploy it and then maintain it over time and hopefully one day retire it, right? So to do that without friction, with this decentralized model that anybody and everybody, every generalist developer can do that, we have to create this new plane, new set of APIs that allows provisioning, the management, and manage the life cycle of data products, right? Declaratively create them, be able to read data products, be able to version them. Now we're talking about this hexagon, this unit of architecture that independently can be declared and provisioned. Not all of the bits and pieces we need. So that's great. Once we've done that, there's a ton of capabilities that only make sense to be provided to the users of this interconnected mesh of data products at the global level without centralization. And I keep repeating this, hopefully through this, that when you think about your architecture, every time you find yourself building something that totally centralizes and without it, you are not able to use the data products, something's got wrong with the architecture. We're back to that centralization again. So I'll give an example here. Knowledge graphs are the new hot thing. What are they? A way of semantically connecting these different data points together and be able to traverse this graph of relationship of data, right? And an emerging artist is an artist that, gets paid this amount, and these are our emerging artists that emerged last month. This graph of relationships. How do we do that if all of this data, polyglot data, separated? Well, we need to have a schema system that each local data product defines a schema that has semantic links to other data products that they relate to, right? But once you have that, the emergence of that mesh of schemas that are linked together, you need a tool at the global level to be able to browse and search those things. So that's kind of this mesh experience plane that you've got to kind of build. And when you think about that federation governance, okay, what happens to these policies? Like that over time, you probably start with just access control, and over time you will keep adding to them. Well, they need to be, first of all, need to be programmatically built, automated, built into the platform, and then embedded as a sidecar, as library, whatever makes sense to your architecture, and accessed by every data product. I mean, an analogous situation of this is the sidecars that we use in service mission operational world that, embed routing policies and failover policies and all those discoverability policies, all those policies that make sense in microservices APIs. We have an analogous situation here that we need a way of injecting these policies and executing them at the level of granularity of every single data product. So then with that hope, what other architectural components gets packed within this logical autonomous unit of data product? Well, input-output ports need to have, first of all, a standard. You have to have a standard or set of standards that then you can kind of connect these things together, right? So you might say, for my organization, I will provide, SQL access, and this is the API for running your SQL queries on my data product, or this is the interface for getting access to the blob storage, and these are the two types that I only provide, or this is the way to get to the event. So you need to have just standard APIs for exposing your data and controlling and also consuming the data. But then we are now introducing a new port, a new set of APIs. I call them control ports, a way of configuring, whether you are configuring this, policies centrally and pushing them down, cache them in every data product, or just configuring and authoring them locally within those domains, you need to have a way of receiving and changing these policies and then executing them. So you have a policy engine, you have a data product container that contains this new logical thing that has all of those components in it, your code, your storage, the APIs to access to it. So let's bring it all together. This is going to be a hairy diagram, so hopefully you can follow me. So we've got domains now. Each domain has one or many applications, and there might be services, there might be apps, and one or many data products that are running on your infrastructure within some form of a container. I can talk to how we're implementing that in a little bit. Each of those data products have input ports and output ports, and the data is the only thing that flows between the two. No computation happens in between. The computation happens within the data product. And that computation, as we said, it could be the transformation. You might want to have a pipeline in there, that's your choice, or you want to have actually a microservice in there to do the transformation, it's your choice, however you implement it. You have a lot of other things, right? You've got the data itself, you've got the schema, you've got the documentation, you've got your other services probably running in there. And when you think about your mesh, I didn't really depict this here. I wish I had a better, I was better at drawing, or I had the patience of actually digitize this. But there are 3 layers of interconnectivity on the mesh. The first layer is the flow of the data, right? Between input ports and output ports. It's your lineage, essentially. The second layer is the links between your schemas, the semantic links between the schemas, so that you can join these things. So you need to use a schema language that allows a standard way of semantically linking these fields together. And the third layer is the link of the data itself. This listener is this user. If this is the listener versus the user domains. You have a different port. I'll call it the discoverability or discovery port, which is essentially your root API. If I access pink data product here, the root API, the root aggregate for that should give me all the information so that I can discover what is in it. What are the output ports? What are the SLOs? Where are the documentations? Where do I actually get the data? How do I authorize myself? And the control port, which is a set of APIs for configuring and configuring the policies essentially, and maybe some highly privileged APIs that maybe you want to, you want to embed there that only governance folks can execute. What is the platform? So we talked about 3 planes, right? So the plane that I think is really important to focus on if you get started is this data product experience plane. So you might have an endpoint, your lollipops, your API data product deployments that allow you deploy, give declaratively deploy your data products. Then that plane uses the utility plane, provision a blob storage, because my output port happened to use blobs. And on the mesh experience plane at the top, you have mesh level functions, right? Search, browse, those are the APIs that you probably want to expose up there. All right. I have to run really fast because I've been told to talk only for 25 minutes maximum. I've got 22 minutes. Let's see how we go. So how do you go about architecting this thing? Here I want to share 3 tips with you. Start with your data product. Start with designing what is this data product? And I have given you some pointers as how to think about it, right? What are its components and elements? Once you start from there, then you can figure out, okay, if I want to provide all those usability characteristics I shared with you a few slides back, and I want to delight the experience of my data analyst and data user, any form of data user, then what are those APIs for my platform that I need to provide? And then you figure out the implementation. To be honest, we've been around this block for 3 times already. We've built 3, 4 different versions of this experience plane and start very primitive with a bunch of, scripts and templates that you can use. And now we're very sophisticated. And I show you a spec file. We pass a spec file to an API and a command. So go top inverted model of purpose, right? Inverted hierarchy of purpose from your data products, and then design that. And learn a few lessons, 1 or 2 lessons from complex systems, right? Think about how the birds fly. The birds don't have an orchestrator or a central system who manages them. They just have local rules. I follow the leader and I don't run into the other birds. That's all I need to know. And then from the interaction of all the birds following those local rules emerges this beautifully complex flock of birds that fly long distances. So apply the same complex adaptive system thinking. Your schema, you don't need a highly elaborate schema that covers all of the domains, but you need a standard schema locally defined, as in standard model of defining the data globally, but locally defined schema, and then connect them. Think about that affordances. Okay, what are the capabilities I need to provide by a single data product? It needs a service data. It needs to secure it locally. It's a decentralized model. So these capabilities should be, or affordances should be available to the users locally. So let's dive into one of those. You manage the lifecycle. I need to be able to independently deploy this thing without breaking all the other data products, without upsetting its users, and over time. So, and we talked about I need to pass the code into this lifecycle management. I need to pass some sort of a model spec that says what is this data product, because we want to abstract away complexity of how to configure it, and we want to have a declarative way. So this is a few lines of a long, much longer model spec for a data product that says what is this input ports and output ports, and maybe some of the policies that it has, and pass this through the life cycle of, check this code in your repo of that data product, pass it to your experience plane API that then, platform of choice, I've borrowed this diagram from our teams that uses Azure for implementation, and then pass that to utility plane to configure all of the bits and pieces that you need. And it's going to be, I have to be honest, ugly a little bit at the beginning, and it is already, because we don't have that beautiful, simple, autonomous unit that you can deploy and does all of the things that I talked about today. When we started with microservices, we had one thing. We had a Unix process, this beautiful Unix process. Then we had Docker containers or other form of containers that encapsulated our autonomous units of architecture. We don't have that in this big data. So our big data autonomous units of architecture data product looks a little bit like Frankenstein creations, to be honest, because you have to stitch in a lot of different technologies that weren't meant to be decentralized. But it is possible. It is possible, and I'm hopeful that AI technology will catch up. Let's look at one of those other affordances. So let's say you're designing your output ports, right? You're designing serving the data. To me, these characteristics of an analytical data that's served is non-negotiable. Your data needs to have some sort of multimodal access. If not, you have to then, all of your data gets dumped into some warehouse somewhere else. We're back to centralization. I highly recommend design your APIs to be only read-only and be temporal, time variant. If it's not, then somebody else has to turn it into a temporal, time series data. And you want that to happen locally here. And most importantly, immutable. The last thing you want is some data for a snapshot point in time changes and the cascading effect. So the function, the read function of these output ports is always function of time. From what time to what time? And we can talk about this, I think a whole other talk about how to deal with windowing, time windowing, and temporal information. I think we're lacking standardization, to be honest, in this field. And once you decide like what data, at what time, what duration you want data, then you have a choice of saying, oh, actually, I want this data in the form of graphs or semi-structured files or events. This is a spatial topology. So polyglot data means that you might have many different spatial topologies of that time variant data. So if you have an app developer is looking at the data, the same data, like media streaming usage or play events, they may want to pop sub access to an infinite log of events. Your reports guys probably don't want that. They want a SQL access so they can run some of their queries here locally on the data product. And your data scientists want something else, right? To do feature design. They want a columnar file access. So in short, the output port definition and design of these output ports would need to satisfy the kind of these affordances we talked about. Serving temporal data, time variant data, polyglot data for the same core semantic of information. I know there was a lot to take in. My talks these days are just getting faster and faster because there's so much I want to tell you. But if you want to learn more, I'll put a few references here. My kind of semi-recent article on Martin Fowler gives you a flavor of the architectural discussion we had here. There is a wonderful community. I didn't create this. This is a kind of a grassroots movement. It started around data mesh learning. Please join. And I will have deep dive tutorials of multi-day tutorials hosted by DDD Europe, wonderful folks in Europe, but we do US time zone and Europe time zone. That I will go deeper into the design of each of these architectural aspects that we talk about. Thank you for hanging with me and being interested in data mesh. So I'm excited what the future holds for us. Thank you.
So I was telling everyone that we are already running out of time, but we have the Hangout room. The link is on the chat and also on the schedule page. And also after this, we have the panel, and Zhamak's going to be there, and we can follow up with the questions. Great work answering almost all the questions in the chat. But we have time for, if you can answer in 3 minutes, for one question. So I'm going to ask you a question that came from the other session. When is not a good idea to use data mesh?
Yeah, I mean, that's a great question. Any distributed system, any decentralized system like a data mesh comes with complexity, right? Managing this independent units and yet have harmony. So if you don't have the pain points that I mentioned earlier, the scale of diversity of sources, scale of the origins of the sources, scale of those very diverse domains and use cases, multiple teams that need to be autonomously responsible. If you don't have that, it seems like a hell of an over-engineering to build the data mesh. So it's really the motivation for data mesh were around organizations that are growing fast. They have many domains, many touch points, and great aspirations. And hopefully your organization get there someday, but if you're not there yet, I don't think it makes sense. The other thing I would say is that if your organization right now, it's a matter of also when, right? Right now, we are really in the innovator adopter or the lead adopter curve of adopting something new, and the technology that you can just buy off the shelf or open source use is limited. So you still have to do quite a bit of an engineering to stitch what exists today in this distributed mesh. And if you don't have the engineering capacity, bandwidth, or just your organization likes to buy things and integrate, perhaps right now is not the right time, even though that you might have the scale.
Excellent. So let's go to the Hangout and hope to see everyone in the panel in a few minutes. Thanks a lot, Zhamak.
Thanks, everyone. See you there.